Hello, you're welcome to this video on skew lines for Leaving Cert DCG. Modelled here in front of us is the just a parametric model of two skew lines, my red line A to B and my blue line C to D. The theory behind skew lines is that they have to be non-intersecting, non-parallel. So two lines that cannot intersect each other and cannot be parallel. They cannot intersect in the portion that we can see, or if both lines were extended, they cannot intersect. They can't be parallel, and parallel lines, of course, are parallel in every possible view, which very obviously these are not parallel. They're also obviously not intersecting. It's not always as obvious on paper though, because when I project in my elevation of those two skew lines right there, and we see the elevation there, it appears like they're crossing. Well, that's just because in one particular view it appears that the lines cross there, and in a lot of different views it appears that they cross. But notice that right now the point that they appear to cross is down near the end of the blue line. If I move this around, the point that they appear to cross is up near the top of the blue line. If the lines cross and intersect, well, they have to intersect at the same point. The point can't move. It's not a dynamic point, it's a fixed point. So what I mean there, and another little bit to bring on with that, would be there they appear to cross as well in plan, but the point of apparent intersection here and here don't actually line up with each other, so it wouldn't be possible that those two lines are intersecting lines. The bit of theory we need to know. Okay, so what we're going to be looking for here is we're going to be looking for some distances between the lines. And if I suppose just to very briefly and quickly give a little some little examples. If I just get rid of those sketches again of the elevation and plan. If this was the flight path of one plane descending towards the runway, and this was the flight path of another plane descending towards the runway, there'd be a minimum regulation of the closest possible distance would have to be not less than, let's just say, 500 meters. So that would be one application. It would have to be calculated by the flight paths of both, the minimum distance at their closest point. If there was a cable buried in the ground in a known location and you needed to drill or bore a hole in a second location to reach something here, well, there'd be a minimum distance maybe you have to keep away again, shortest distance from line to line. If there was two water pipes in the ground and you needed a horizontal access point between them, you'd want the shortest horizontal distance between the two. Maybe if these were two access chambers for mining and you wanted an escalator between them that would raise you from a point up at 30 degrees, let's say, you wanted a 30-degree escalator going between the two, well, that would be the shortest 30-degree distance, because, you know, if you're the one calculating here and you had to pay for an escalator to go from one main access tunnel to the second one, you're not going to want to make a huge long one here if you can do the shortest possible one in here someplace, possibly in there someplace. I don't really know yet where it is. That's part of the problem that we need to solve. Maybe you're a surgeon and there's a main vein running down and you want to make an incision and you want to make sure you remain away from it, and that would be the path of your incision right here. So look, there's lots and lots of different applications that you'll have heard of, or that I might have come up with as well. But there's a lot of theory, or a little bit of theory at the back of it, and there's some principles and practices that you'll have to learn. So, without further ado, let's get drawing. There's our elevation and our plan. What we need to do is this, okay? I just have a little bit, some notes put up here on SolidWorks. We need to create a plane. We need to create a plane that contains one of the two lines, and it has an edge parallel to the other line, and it has a horizontal edge. So we're creating a plane, and a plane is just a flat surface or a portion of a flat surface. We're creating a plane that contains one of those two lines. So it's going to be starting off stuck onto one of the two lines. It's going to have an edge parallel to the other line, and it's going to have one horizontal edge as well. So they're my constraints. And the whole goal here is this. The goal is to find a view, some view, that shows those two lines as parallel, which would be there, something like that. we need to find a view that shows the two lines appearing parallel. So to find that view, we need to construct, first of all, a plane that relates to both lines. So what do we do? I started off with the red line. The red line there from A down to B. I'm creating a plane that contains that red line. So I think I've that actually color coded. It contains the red line. It has an edge parallel to the blue line. So I've gone parallel to the blue line from the top here of the red line. And it has a horizontal edge as well. And there we have it. There's a horizontal edge there in green that's parallel to the ground. So there's my plane. I have just satisfied the three constraints. And they are three constraints and three rules that you just have to learn off, and that's it. The plane has to relate to both lines. That's why we have to have those constraints. It relates to the red line because it's tied. It relates to the blue line because it is parallel to the blue line. And it has a horizontal edge in for a very good reason. The reason for the horizontal edge is if I can view along that horizontal edge right there, and if I can find a point view of that line, I can find an edge view of the plane. Watch what happens when I find an edge view of the plane. So if I just turn this model around until that green line becomes a point, there. Well, I have now found a view where my red and blue lines appear parallel. So that plane gives me a direction to view the object so that I can see a view showing the two lines as parallel. That's kind of the theory behind this part, and that's the practice we need to learn. In elevation, that's my plane. So containing the red line, parallel to the blue line, which is here, and horizontally across. And down in plan, I've much the same thing. I'm going parallel to the blue line until I find this point right here, of course, which is dropped down from the elevation and projected down to plan. And that's it. Now, I have just extended the horizontal plane because I need to do what I just did there in 3D. I need to take a view that views along that green, that horizontal line, which is a true length line on a plane. And I project up. Now I'm projecting here from that green line in plan, up through and stopping at a point, and I'm going to have to drop in an auxiliary plane, an AVP right there, auxiliary vertical plane. I'm going to project the view onto that plane. So projecting everything from plan up, first of all. Projecting everything from, well, I've just shown it here from just projecting straight off with the 3D. And once I do that, it gives me my blue line in position, and it gives me my red line in position. So that is an auxiliary view that shows the two lines appearing parallel. So there we go. If I just turn it now, when I go as close as I can to it anyway. When I get there, my green line, my true length line, becomes a point view, and my two lines, my red and blue, appear as parallel lines. So that's the background theory that we need first. That's stage one. Stage one, create the plane and find your view showing the lines as parallel, and then we'll go and we'll look at the particular question, whether they asked for a shortest distance between the lines, the shortest horizontal distance, or the shortest distance at a given angle. We're going to go back onto paper for the first stage of this. On paper, we're going to get this far. We're going to create the plane that contains a line parallel to a line, has a horizontal edge, and then we're going to view along and see them as parallel. Once that's done, we're back here onto SolidWorks, and we're looking at the three different ways that this question could be posed after. So just here in my worksheet, you'll see the red line and blue line, just like it was shown there on the SolidWorks model. If you want to draw this at home, I'll just give you a couple of general measurements for this anyway. The line AB, that blue line, or that red line here, sorry, is 70 mil long, and I pitched it off there at an angle of 35 degrees, I think it was. At an angle of, yeah, it was 35 degrees and 70 mil long. Point A is approximately 55 mil off the ground. So 55 mil up, 35 degrees down, 70 mil long. Point D there, like, you know, just pick the position for it, whatever you think yourself really. It doesn't have to be too exact here. I made that blue line 7 degrees of an angle, and it is approximately 62 millimeters long in total, and it just appears to cross right there. Down in plan, then I projected down the end of A and B and the end of C and D. The line AB, I think I made that, yes, just appears about 7 degrees again, just crossing over. And CD there is an angle of 9 degrees. So one thing we need to be absolutely certain of here, and we just need to understand this. So if you're setting up the question yourself at home, the point where they appear to cross in each view, obviously if they're skew lines, those points cannot line up. Because if those 2 points where they appear to cross in one view and they appear to cross in the other view, if those 2 points line up, then that means you have just drawn intersecting lines, not skew lines. Let's get cracking. I want to create my plane. Create a plane that contains one of the lines. It contains the line AB in this case. Now, this can sometimes be the difficult part of the question because there's 4 possible ways to go. It can contain AB and has to be parallel to CD. So I can go down and across horizontal. Or I can contain AB and parallel by going up and across. Or I can contain CD, and look, there's 4 different ways to go. You can contain any line and work from any end, and sometimes it's no problem, you can do it anyway, and sometimes it might not fit in the page. In this case here, I know that I can contain the line AB, the red line. I can go parallel to the line CD, right there, down, parallel to CD. And it has a horizontal edge as well, so that right there is my horizontal edge. And that gives me a point right there. I'll just call that point A, B, C, D. That's point E right there. Okay. I'm going to add just a little bit of colour onto that plane right there that I've just created, because I don't want to see this as just a bunch of lines or a selection of lines and rules. I want to see that as a plane that I've just created, and the plane is containing one line and it's related to the second line. That's the important thing here. It relates to both lines because it's containing one and parallel to the other. So there's the plane right there. Now, working down to plan. Point E I need to find down in plan. It's down here somewhere. Now, where is it? What did I do already? I went parallel from A, parallel to the line CD. So I need to do the same down here. Parallel to the line CD, and notice I've changed my adjustable. I'm changing the angle now, parallel to the line CD. Is that right? That's pretty good. Parallel to the line CD from A. And that parallel, 3 strikes through this time, to the line CD from A, and that gives me the point E right here, and then I'll join E back to B, and there's my green plane in plan. So, the green plane is after being found in elevation and in plan. I've just used my rules that I had there on SolidWorks that were shown on the screen. Parallel, containing one line parallel to the second line and has a horizontal edge. That's a horizontal edge right there. The important thing is, if a horizontal line is shown in elevation, if it's parallel to the horizontal plane, well, it's a true length in plan. So that right there is a true length line. If you look along a true length line, you get a point view of the line. If you look along a true length line on a plane, you get an edge view of a plane. So let's do it. Let's reset the adjustable, taking this as our key angle this time. The angle that this line right here makes. That is the key angle for me to move on. If I view along that line, in this direction here, if I view there, I should get that line EB appearing as a single point, and I should get the plane ABE appearing as an edge view, and what we saw there earlier on in the model, I should also get the red line and blue line appearing as 2 parallel lines. So let's see how that works out. We project everything up, step off at 90 degree, X1, Y1. We take our compass, and this is an auxiliary elevation, so I'll take the heights from my main elevation up here, and that's point B right there. That's point E over here, which is going to be point view of a line. Point D, point A, and finally point C. I'll take my projections up just that little bit further there for point C. And I'm going to just check first of all, before I draw the lines in solid, I'll just check and see how good is this ending up. It's not bad at all actually. And I'm going to draw my two lines. And I'll make sure they're parallel now. So there's one line, that is the line AB, which is, and I might just add in the colour now as well while I'm here and it's all set up. That's the line that goes from point B down below there up to point A up here. A, B. And this one out here is from C, which is up top, down to D down at the bottom, and while I have my two set squares here, again, there we go, point C up top to point D down the bottom. I like to draw them with my sliding set squares. I don't like draw the two lines first and then see how accurate it was after, when you realize that the lines don't look parallel. Okay, so you want to make sure that you check them first of all, and if needs be, you might have to go back and check your setting of your compass. Maybe you went a little bit too high on C, maybe you didn't project exactly from point C, and a few mil here will mean that one line is not parallel to the other, and then that's going to create a bit of a problem going forward. So make sure you check as you go along. Make the clever check now instead of realizing in 3 or 4 steps time. That auxiliary elevation gives us a view which shows the two lines appearing as if they are parallel. That's the first step of this problem done. The next step, we'll go back to SolidWorks and we will have a look at. Basically, there's 3 different ways the question could be posed from here, and we'll explore all 3, and you know, we're going to try our best to get all 3 of them onto this question sheet here. So to take it on to the next stage now, from here we are looking at our two lines appearing parallel, just like we got there on paper. The 3 ways that the question could be posed. So we could be asked for the shortest distance or perpendicular distance, which is the same thing. We could be asked for the shortest horizontal distance between the lines, or we could be asked for the shortest angular distance, so the shortest distance that is at a given angle. Either way, it all comes from here. This is the key point right here. And what we're doing from here on is we are using those to guide us in our next projection. So if we're asked for the shortest perpendicular distance, you look perpendicular to the lines. Or shortest distance is the same thing, you look perpendicular to the lines. If we're asked for the shortest horizontal, you look in line with the ground. So let's just use these as the guide. Okay, these 2 are guiding the way I turn my screen here on SolidWorks, but this is where the actual the action is happening really. So when I turn the screen, I should be my line should be in here. So shortest perpendicular distance means I turn my screen until I am looking in perpendicular to those 2 lines, which is here. So right now, there, at that point right there is where those 2 appear to cross, is the shortest distance between the 2 lines. If I change it up a bit and I use this again, I'm using this view and I look in line with the ground. So if I look in there, in line with the ground, well, where those 2 lines appear to cross now, that is the shortest horizontal distance between the 2 lines. And finally, if I'm asked for maybe the shortest distance at a 45-degree angle, I use my 45-degree viewpoint like that, and that is the shortest distance. So this view right here is just a view that shows the lines parallel, which allows us to direct our next auxiliary. Now, what are we looking for first? First one I'm asking and that I'm going to do is the shortest distance, or like I have in brackets there, shortest perpendicular distance. Look down perpendicular to the two lines and project out your next auxiliary view. So let's see that one happening. Okay, I had to extend on my AVP, my auxiliary. I'm projecting everything down perpendicular to those two lines, and there we are. Everything is projected down perpendicular to the two lines, and I dropped in my x2, y2. From there, I put a plane on. So there needs to be a plane here to project my lines onto. What happens then? We project out along the plane, and we take our distances back to the red, back to the blue. Where did those distances come from? Well, don't forget, if this view here, if we were looking for the distances out to this view, we will always skip one view and work back. Why does that work? Well, watch this. Shortest perpendicular distance, as I said, look perpendicular to the lines. Once I turn SolidWorks until I am perfectly perpendicular to these two lines here, or as close as I can make it now on screen, there we are. Look at where our auxiliary view, our first auxiliary view is right here, and our second auxiliary view is perfectly behind the two lines. It is a representation of what's happening with those two lines in this particular view. So that second auxiliary gives us a crossing point, or what appears as though the two lines cross. That right there is the shortest distance between the two lines. It is a point view of the shortest distance. So what do? We take it, we bring it back up through our views. We project it up to our first auxiliary here, and this line in yellow is the shortest distance between the two lines. How do I bring it down here? Well, watch it on SolidWorks. Projected from the point on the red line and the point on the blue line. And there we go. Shortest distance between the two lines found. Once I turn back again to look perfectly in at this view here, which was perpendicular to the lines, that yellow line becomes a point view. So just watch it once more now, and we'll get back to paper then. When I can see perpendicular to these two lines, my yellow line becomes this point view down here. So just keep an eye on it, and there, we're just about there. That is the shortest distance between two lines, or the shortest perpendicular distance between two lines, the first one. Done. Okay, I'm going to flick back onto paper. We're going to do this one on paper, and then we're going to move on, and we'll do the shortest horizontal distance next. Now, having seen that there on the model, we should have no problem in knowing what's coming next here. I'm going to take just a perpendicular line. So first of all, I'll set up my adjustable here for this. I'll go parallel to the lines. I'll go directly in line with the longest one there. I'll just check it on the shorter one. That's perfect. And I'm going to project through point C perpendicular to the lines. Through point D perpendicular to the line. And finally through B and A. I'm going to drop in an X2, Y2, right there. What should I do now? Well, I should do exactly as I saw there in SolidWorks and take the distances back to my plan view down here. I don't really need point E right now. I need AB, I need CD. Now the largest one there is A, and it's just so big, it's probably, it might just about fit on the page, but I don't really want my drawing to get that big. So what I'm going to do is this. I'm going to just take the angle of the XY, and I'm going to reduce every measurement. I'm going to reduce them all back by a little bit. I might put a reference line in right here on B. I'm going to put that in there in a different color that I haven't used, in yellow here. So that right there is a reference, REF line. But what that just means is that I have just shaved about 80 or what have I? 87 or 88 mil. I've shaved 87 or 88 mil off of every compass measurement. It just stops my drawing of going way out on the off my page, maybe even. First off, point B is now at a distance of 0, so I'm going to be, instead of setting my compass to 87 mil there to get point B, I'm just setting it to 0. So point B is right there at a setting of 0. Working out to point A, and up to A. Okay, and I like to label as I go because I think it's the safest way to do it. Just make sure that if we have lots and lots of points to take, we won't make a mistake along the way. Point C is here. From C is here. Point D from my reference line up to D, from D up. Now I'm close to the elevation there, and I'm going to make sure we don't make any mistakes, foolish mistakes like that, joining it onto the elevation or anything. Point C and point D define that blue line in this position. Point A and point B define this red line in this second auxiliary view. And where those 2 points appear to cross gives me the shortest distance. Now I'd like to just add a little note, and I'm going to add a lot of notes in here and maybe colour and all at the end of this. Right there, that is a point view of shortest distance line. So where those 2 appear like they're crossing right there is a point view of the shortest distance line. Like we've all always known, if you have a true length line in one view and you look along it, you get a point view in the next. So this is just that same rule worked backwards. If we have a point view line in this view, we have a true length here. What colour I had used, actually, that's it. I didn't think I'd need the yellow, and that's why I used it for a reference, but I had used yellow as my reference colour for the shortest distance line, and there it is. That is a true length of the shortest distance line. I'm going to take it down to plan now. I'm going to take it, of course, I might just use adjusting. I'm not going to change my adjustable set square for that. I'll use sliding set squares. So parallel to my projections again, and just be very careful in your setup for this. The yellow line starts on the blue right there and goes up to the red right here. And get this one right, make sure it's accurate. So it goes from the red down to the blue. That is the shortest distance between those 2 lines. And of course, in a question they will say show the projections of the shortest distance, which means projections means in every view short. Let's go take that one too now. I'll just go back again and there. That is the shortest distance between those 2 lines. Right there. No. That's the first one. So when you look perpendicular to the 2 lines, you get the shortest distance. I'm going to add more notes after. I want to see how much more I need to draw on this first of all before I add any more notes. For now, we'll get back to SolidWorks. I'm putting 3 questions all in one. That might be the solution to the question you're asked if it's shortest distance. I'm going to put 3 questions all together on this page. So don't be confused. I'm just saving myself a lot of time and saving 2 extra sheets of paper here by doing this. Now, as I mentioned there previously, we have to base everything on this view here, which shows the 2 lines appearing as parallel. And from there, if the question was posed shortest distance or shortest horizontal, you'd look or sorry, my apologies, my mistake. If the question was posed shortest distance or shortest perpendicular distance, you look perpendicular to the lines, you get your shortest distance from the point view down here, and it's projected back up through the views. And there it is, shown as a true length here in yellow, and shown as it appears in the 3D here, which is just projected up to the elevation, down to the plan, and so on. The question may have been put, and this would be a very common one, as to find the shortest horizontal distance between the two lines. So maybe there needs to be a horizontal walkway between two subway lines or something, and to find that, from the view where the two lines appear parallel, we look in line with the ground, in line with the x1, y1. And this is what it looks like. So I have my arrow in there, and that arrow is parallel to the x1, y1, the baseline that this auxiliary view is built upon. So let's project. We project across in line with the x1, y1. Hard to see it here, maybe in green, but in line with the x1, y1, and we pick a point to stop for our next plane, and there it is. That's the plane. It comes straight out from the first auxiliary vertical plane right there. And we're just going to go ahead and do the same process as before. It's just a different viewing direction, and that's all. So the green lines come out. My distances come back from the plan here, or from the plan, of course. The distances from the auxiliary elevation back to the plan marked out here. And we get our red line, we get our blue line. And where do they come from? Let's just see this now for a second. Where do they come from? They come when I view in the direction of the arrow. So I want to turn it now until that, the one select for me there, I did for a second. That x1, y1 line right there, I want to see that line as a point view. So if I keep turning until that line becomes a point view, there, something like that, let's say. My projections, and we can see they're just slightly off there, but they are perfect. It's just turning us in SolidWorks doesn't always turn perfectly. The two lines as they appear are at the back of my three-dimensional right there. So there they are at the back of the 3D. And that point where they appear to cross represents the point view of the shortest horizontal distance line. So I'm going to take that back through my views. Let's see this. Comes from that point, it comes back up to the x2, y2. It comes right in along. And right here, that is the true length of the shortest horizontal distance projected down to plan. Now this is getting a bit busy down here now. Projected down to plan and drawn. That is the shortest horizontal distance between those two lines. So shortest distance there in yellow clearly is a good bit shorter line than this shortest horizontal distance. Now, if I haven't confused you yet, don't worry, I will. There's one more view still to come of this. But that is shortest horizontal distance. Let's get back to our worksheet and let's draw this. So for this same set of lines, we're going to go ahead and add in our next solution to a problem. And this time we're going shortest horizontal distance. So we've shortest perpendicular distance looking perpendicular to the lines. Shortest horizontal distance looking at the two lines parallel, viewing direction to what we have here, to the x1, y1, or to the ground. So set up your adjustable parallel to the ground. Where are we now? There. I think that's about right. Set the adjustable parallel to the ground, and depending on where you have space, really, I'm going to look down. True. I know on SolidWorks model I looked up. True. But it doesn't matter. Look down through the two lines. So we project on point B, point D, point A, and finally point C. We put in. This is really it's I suppose we could call it an x2, y2 again, but it's just the next auxiliary again linked onto that. But I've already used x2, y2, so I'm going to use x3, y3 this time. It's another auxiliary. Realistically, these are two completely separate questions. The question finished here. Now I'm starting a new question, so it's going this direction in line with the ground for the shortest horizontal distance. Same process here for finding my points. Again, I don't want to be taking these huge measurements back, so I'll shorten it all up. Point B lies on where I'll be putting my compass this time, so B again is right there. I'm going to take point A next, so I have the two ends of that single line right there. A is here, taken down and marked. Okay. I want to go back and find my point C distance. And don't forget, all I'm doing here is I'm skipping a view and working back from the XY line ideally, but we don't have space. So back to C and down to point C. Last point. Down from the reference to plan, down to D. And out here to D. There we have it. Our two lines appear to cross in this view. Now where they appear to cross, I'm sure as you know now, where they appear to cross in this view gives us a point view. Of the shortest horizontal distance line. If it's a point view of a line here, it's going to be a true length back here in this last view. So let's project it back. Let's take that back through, and from that point I'll take it back through the views. There we go. What colour did I use for this one? If I just recheck here on SolidWorks again, I used green for this one, so I'm going to use green again here, keep it all consistent. That right there is the shortest horizontal distance between the two lines. I think this time, because I've set up my adjustable in line to look along with the XY line, X1, Y1 line direction, I think it should already be set to the correct angle for projecting down to plan. Well, the end of the green line is right there. And the end of the green line is right there. And the red. And where is it? It's there. There we go. That's our shortest horizontal distance. Right there. Little bit of a change there from the yellow line. I'll bring them up to elevation next. Into the green line and the red. Into the green line and the blue. We should find, just check that again just to make sure. Yeah. What we should find is that it's a horizontal line up here in elevation as well. If it's a horizontal line, it must be horizontal in every elevation. That's the point that's projected up from the blue there in plan and projected up from the red. So that's the shortest horizontal distance found. We're going to go back to SolidWorks for one final round of this. 3 different questions, of course, being compiled into one final round of this now in SolidWorks, and then I'm going to pause the video once we have the final round done, add some colour and see what this is all like. Oh, you'll be delighted that this is the last of the 3 methods here that we're going to be looking at, and again it's all based on the parallel, the lines appearing parallel, and it's the shortest angular distance. So if there's a given angle, and in this case I set it up as the shortest distance at a 45-degree angle, so the shortest line that connects these two skew lines that would happen to be pitched up at a 45-degree angle to the horizontal plane. And I'm really not going to spend a lot of time on this one because I think that it's probably going to be quite obvious what's going to happen. We'll view them. Everything is viewed based on the X1, Y1, based on the view that shows the two lines parallel. If it's asking for a 45-degree angle, draw a 45-degree angle based on the ground. Up at 45 degrees and put in your plane. And that's it really. We could stop at that now and you'd probably just get the rest of it and be able to draw the rest of it, no problem. I'll flick through it quickly, I'll draw it on paper. So this view here, showing them as parallel, we pitch up an angle of 45 degrees and view, and we put our x1, y1 line in. We project out through them views and we get each line appearing up here. And appearing is, they're appearing in a different manner again this time. Now everything's going to look a bit crazy this time because there's so much going on in this model. But that is the shortest distance, the shortest line is at a 45-degree angle is right there. And we project that back through the views, back down, and there it is in pink. Okay, bringing it on out from there out to my 3D right here. And I understand this is really busy now at this stage. It's hard to even see what's going on with it, but if it's possible at all to see it, there it is. I have my shortest distance in yellow, my shortest horizontal distance in green, and my shortest 45-degree distance in pink. There's the tree. And they all just come from different ways of viewing my parallel lines. So let's get back onto paper. Let's get this thing finished. And that is a real crash course, but a fairly comprehensive crash course, I think, in all things skew lines. So as I said there, last step, thank God, the last step on this is the shortest distance. That is, the shortest line is 45 degrees. And as I said, I'm going to take the angle of the x and y1 line here, and then I'm going to pitch off and view at 45 degrees. So let's go first. Based on the xy line and adding 45 degrees onto that, I'm going to project over here. And I should probably put in my projection arrow here just to help me with my notes after when I'm putting notes on this. That is my viewing direction right there. I've taken point C, I'll now take point A. I went really heavy on that first one there, I really shouldn't have done that. I'll move off my T-square for a minute and I'll hold the set square and do sliding here. And I'll take those 2 points as well. I probably need to extend them on a little bit further. I'm going to try and keep these views from overlapping if at all possible. So I'll just extend them out as far as they need to go, or as far as I can go. And there we go. I'll lighten this line. I drew that way too heavy there. And now this guy goes back in again. It's all based on the adjustable this time, of course. If I project it out at 45 degrees, here I'll use the 90-degree corner there to set up my next view. I'm going to move out past this one that was down here, and I'm going to drop in my x1, y1. I should say, I was x3 last time, I got x4, y4, because it's just another auxiliary view. I'll repeat the process of finding my points here, with point B being on the reference line. Point A. Point C. And point D, finally. I'll draw the lines as they appear in this view. That's the blue line as it appears in this view. And there's the red, like the previous drawings. I labelled that as the point view of the shortest 45-degree line. obviously the shortest 45 degree line that touches both skew lines right there. I'm going to project the point view based on the angle of my original projection, and I'll project that back up here. And what colour was that? That was a pink line, so as I remember there in SolidWorks. So I'll just keep with my colour scheme again. There we go. That is the shortest line that lies at a 45 degree angle to the horizontal plane. Show the projections of it. Well, I need to bring it back down. There it is, just inside there, in plan. It's right along there. And finally, up to the elevation. There we go. So I'm going to just pause the video for a minute. I might just, what I'm aiming to do here really is just to define where my planes are. And I think that, you know, if I haven't confused you yet, I think I'm not going to at this stage. If you understand this, it's not that hard to understand. I think sometimes if you just see it in SolidWorks and take your time and learn it and understand it. But really, I think the main thing is that we need to get to grips with where everything comes from. And the fact that I just answered 3 questions all in one here. And it's all based on them planes that I have right now. And the fact that all these auxiliaries are lining up and joining up together. So I'm going to just take a minute here and add some colour and add some labels onto these planes. I'll freeze the video for this job because it could take me a little while. And then I'll just resume the video for the final minute or two then. Now the little bit of colour is added in there, I think it might help maybe with the fact that there's a multitude of questions answered here all in one. Hopefully the bit of colour and label will help with that. I've just labelled here that this is the AVP here, the auxiliary vertical plane in blue. The auxiliary elevation shows the lines appearing parallel is shown. So that's the main purpose of that view. From there then I have 3 different second auxiliaries dropped in, and each one is an auxiliary plan. So every one of these is an AUX auxiliary plan. Okay, this is an auxiliary plan, AUX plan, and this is an auxiliary plan. So I'm not going to add colours onto the main horizontal, or will I could easily, I suppose I could add and make sure that that one is blue anyway. That's the main thing. That one has to be blue, because if I've looked up here at this one, that's a blue plane. So that would be a blue plane to match the main vertical plane, my auxiliary vertical right there. But the colour of this one here, I don't know what it would be. It depends. It could be yellow if it was this one, or it could be green or purple. You know, just look, it's all anything here really to help. We won't be too technical about it. Anything to help with visualising what's happening. The extra little notes I added in there up around here are just all around the viewing directions and the resulting view that comes from that viewing direction. And I think that that is probably after the initial step here of creating this green plane, the next most important step on this drawing is knowing which direction to view or to project your second auxiliary ash. So that is definitely one of the key areas. So that's why my colour is in. That if you're looking for the view perpendicular to lines for the shortest distance, so that's what I have here, and my arrow, and that's the yellow point with the yellow plane, which shows the point view of the shortest distance line here brought back through. Parallel view parallel to x and y1 for the shortest horizontal, so parallel to the x and y1 viewed down here for the shortest horizontal distance. And then finally view at 45 degrees up for the shortest 45 degree line, shown as a point view and projected back through. So 3 different solutions there to 3 skew lines questions, all on the one page. I suppose it's a shame to get this far without adding some little bit of colour. I'm just going to put the horizontal plane in there as brown for now. I'm not going to be too careful about this, really. Just get a bit of colour on it just to finish it off before we sign off in this video. I really hope that this video might clear up and make skew lines a little bit more understandable. Hopefully it didn't confuse you too much. Instead of getting too hung up on this question, you know, best thing to do is lay out the question like I did and photocopy it, or lay it out 3 times and solve each of these in a different on a different sheet. So solve your shortest perpendicular, shortest horizontal and shortest angular. Solve them on 3 different pages instead of all in the one, if that's what you want to do. To condense it all and get it all into one nice neat video, I wanted to get them all into one page, which has worked out pretty well for this question, I think. I really hope this video is helpful. Let me know in the comments if you have any feedback on it, or if there's any other further videos you'd like to see. Thanks very much for watching.